Close your eyes for a moment and imagine biting into a fruit no human has ever tasted. And no human ever will, not because it is hidden deep in some unexplored jungle, but because it vanished millions of years ago, leaving behind nothing but faint impressions in stone and fragments of fossilized seeds. Entire orchards once stretched across ancient landscapes, heavy with unfamiliar colors, textures, and flavors. Yet today they exist only as echoes, silent, unreachable, and permanently lost to time. We often think of fruit as something familiar. Mangoes, bananas, apples, grapes, sweetness shaped by evolution and refined by human cultivation. But the fruits we know today are only the latest versions of a much older story. Long before humans, before mammals, even before flowering plants dominated the land, Earth was producing structures that served the same purpose as fruit, protecting seeds, aiding reproduction, and shaping ecosystems in ways we are only beginning to understand. To uncover these lost fruits, we have to travel back to a time when the idea of sweetness itself may have been entirely different. More than 300 million years ago, during the late Paleozoic era, vast swamp forests covered much of the planet. The air was thick, humid, and rich in oxygen. Giant insects moved through dense vegetation, and amphibians thrived in shallow waters. Yet if you were to walk through these forests, you would not find anything resembling an apple or a berry. Flowering plants had not yet evolved. Instead, reproduction depended on spores or primitive seeds. Among the dominant plants of this time were seed ferns, an extinct group that blurred the line between ferns and modern seed plants. One of the most well-known genera, Glossopteris, produced seeds that were not enclosed in fruit as we understand it today. Instead, these seeds were exposed or loosely associated with leaf structures. Scientists believe these early seed systems represent a transitional stage in plant evolution. They were not fruits, but they were part of the long evolutionary path that would eventually lead to fruit-bearing plants. What did these early seed structures taste like, if they had flavor at all? There is no direct evidence. Fossils preserve shape, not taste. But researchers suggest that many early seed plants likely did not invest in sweetness or attraction. Unlike modern fruits, which evolved to entice animals into spreading their seeds, these ancient plants relied on wind or water. Flavor as a strategy may not have existed yet. That changes dramatically in the age of dinosaurs. Around 140 million years ago, during the early Cretaceous period, something revolutionary appeared: flowering plants, also known as angiosperms. At first they were small, rare, and easily overlooked. But over millions of years, they began to spread, diversify, and transform ecosystems. With them came a new innovation: true fruits. Fruits are more than just food. They are evolutionary tools. They protect seeds and often encourage animals to carry those seeds away. This relationship between plants and animals would reshape life on Earth. Early angiosperm fruits were not like the juicy fruits we enjoy today. Fossil evidence suggests they were often small, simple, and sometimes dry. Some resembled pods, others were hard and nut-like. One example comes from fossil discoveries of ancient magnolid relatives, which produced clustered fruiting bodies that likely split open to release seeds. Over time, however, fruits began to diversify. Some developed fleshy tissues, others evolved bright colors. These changes were not random. They were responses to the behavior of animals, especially dinosaurs and early birds. Scientists believe that certain prehistoric fruits may have been adapted for consumption by large herbivores. Thick skins could protect seeds as they passed through digestive systems. Strong fibers may have helped seeds survive long journeys. Yet this relationship raises an intriguing question. What did these fruits taste like? There is evidence suggesting that early fruits were not particularly sweet. The high sugar content of modern fruits is largely the result of coevolution with mammals and birds, especially in the later Cretaceous and Paleogene periods. Earlier fruits may have been more bitter, fibrous, or even mildly toxic in large quantities, designed to be eaten selectively or processed differently by ancient animals. One fascinating, extinct plant group that may have produced unique fruit-like structures is the benedictils. These plants, which thrived during the Mesozoic era, had complex reproductive organs that in some ways resemble flowers. Some researchers suggest they may have produced structures that attracted insects, possibly even early pollinators. While not true fruits in the modern sense, these reproductive systems hint at a world where plant-animal interactions were already becoming sophisticated, but many of these lineages vanished before their full potential could be realized. At the end of the Cretaceous period, around 66 million years ago, a massive extinction event reshaped life on Earth, triggered by an asteroid impact and possibly intensified by volcanic activity. This event wiped out non-avian dinosaurs and dramatically altered ecosystems worldwide. Plants were not immune, many species disappeared, and entire ecological networks collapsed. In the aftermath, new opportunities emerged. With dinosaurs gone, mammals began to diversify rapidly. This shift had a profound impact on fruit evolution. Mammals, especially those that relied on smell and taste, became key seed dispersers. Fruits responded by becoming sweeter, softer, and more nutritious. But not all fruits made it through this transition. Human activity has had a profound impact on plant life. Through agriculture, deforestation, and climate alteration, we have shaped the distribution and diversity of plants across the planet. In some cases, we have preserved certain species by cultivating them. In others, we have contributed to their decline or extinction. There is evidence suggesting that some plant species, including fruit-bearing ones, may have gone extinct in part due to the loss of large animal dispersers. When megafauna such as giant sloths, mammoths, and other large herbivores disappeared, the plants that relied on them for seed dispersal faced new challenges. Some adapted by shifting to smaller animals. Others declined. This raises a fascinating idea known as evolutionary anachronism. Some modern fruits, like the avocado, are thought to have evolved to be eaten by now extinct megafauna. Their large seeds and thick flesh make more sense in the context of animals that no longer exist. If this is true for living fruits, imagine how many ancient fruits were perfectly adapted to creatures that vanished millions of years ago. Fruits that were never meant for us. Fruits that depended on dinosaurs, on giant reptiles, on early mammals with behaviors we can only infer. And when those animals disappeared, so did the fruits. What we are left with is a fragment of a much larger story. Every fossil fruit, every preserved seed is a clue, a snapshot of a moment in evolutionary time. Together they reveal a world of experimentation, adaptation, and loss. Some ancient fruits may have been incredibly nutritious. Others may have been toxic. Some may have had flavors we cannot even imagine, shaped by chemical compounds that no longer exist in modern plants. We will never know exactly what they tasted like, but we can understand their significance. These lost fruits were not just curiosities. They were part of complex ecosystems. They fed animals, influenced behavior, and contributed to the cycling of nutrients. They helped shape the environments that eventually gave rise to the plants we depend on today. In a way, every fruit we eat carries a legacy of those that came before. The sweetness of a ripe mango, the acidity of a citrus fruit, the texture of a banana. These are the results of millions of years of evolution, built on foundations laid by plants that no longer exist. And the process is still ongoing. Even today, plant species continue to evolve, adapt, and sometimes disappear. Climate change, habitat loss, and human activity are accelerating these processes. The fruits of the future may be very different from those we know now. Some may never come into existence at all. As we look back into deep time, studying fossilized plants and ancient ecosystems, we are not just uncovering the past. We are gaining insight into the fragile, ever-changing nature of life on Earth. A reminder that what exists today is not permanent, that entire worlds can rise, flourish, and vanish, and that somewhere in layers of rock beneath our feet lie the remains of fruits that once grew under alien skies, nourished creatures long gone and disappeared without ever being tasted by human lips. Their story is silent but not lost. It waits in stone, in patterns, in the careful work of scientists who piece together fragments of a forgotten world. And if we listen closely, we can almost imagine what it would be like to stand in those ancient forests, reach out and taste something completely new, something impossible, something that belongs not to our world, but to a version of Earth that is gone forever.